All right, how's everything going? We're week 9 out of 10. The end's coming fast.
9 out of 10 IGN.
Yes. All right, so things to talk about. PA4 is graded. You have comments, you have grades on there. So good work with that. Deletion and BroadestFirst Traversal, right, we expected those to be the trickiest spots, and that's not a huge deal. We'll look at some sample code. But basic mechanics, tree manipulation, building nodes from nothing, moving through a tree, linking things together, right? That seemed to work for most people, which is awesome. We'll use trees a fair amount in 223, so we want to be pretty fluent with this idea. We're kind of taking a break from those kinds of data structures in PA5. You probably don't need any mallocs for PA5, so it's a little bit of a different track. But I think people are in good shape as far as trees and tree operations. ODPs are posted for this morning. I'll post another one for tomorrow morning. This morning's ODP is more file processing. So open a file, read one line at a time. If that line begins with an integer, add it to a running sum. If it does not have a valid integer, just ignore that line. Keep going until you get to the end of the file, and then your function returns the running sum. And I put a sample of a file and what it might contain and what you should return. And this is a slight modification to the ODP you already did. The main difference is you need to loop, and one way to loop is look at the return value from fgets. So while null is not fgets, and your usual, give it an array length and a file pointer. And then do whatever you need to do in here. So remember, fgets takes an array of characters, the number of characters in that array, and you don't need to subtract one. If buffer is 120 characters, you can give it 120. And it will only use 119 to store characters, and it'll use the last one for a null terminator if necessary. And then the input stream, standard in if you're reading from standard in, but fpin, the result of fopen, if you're reading from a file. And fgets will return a null if it hits the end of the file. So standard in, that's a control D, reading from a file on disk, that's when it tries to read past the end. And then inside here, you can do something like if 1 equals scanf, and try to scan with a %d or a %i. And if it returns 1, it got a good integer, go ahead and add that integer to your running sum. Otherwise, you don't have to do anything, just go back to the top of your while loop, read another line. When you get to the end of it all, right, close your file just to be clean, and return your sum. That's what? I saw you were going after character by character. Yeah. Yeah, because you were one of the first to get to work on it, so I was just peeking. Yeah, fgets, if you want to do a line at a time, right, it does all that work for you, so that makes things a little easier. Wednesday, I have a former student who is working various things. One of the things he's gotten himself involved with is a bunch of coding schools for kids. And it's a business that apparently, it's a nonprofit, and it's apparently taken off significantly, and they're desperately looking for teachers. So he asked if he could come and talk to my classes. So he's going to come in at the end of this class on Wednesday, and then the beginning of the 12 o'clock class, and probably talk for 5 or 10 minutes, just kind of about what they're doing and what they're looking for. I don't know any details beyond that. That's why he's coming out. But possibility of, I don't know, part-time work, summer work, who knows? Basically teaching kids to code. So we'll do that Wednesday.
Wait, isn't it on like the Clark website, is it the jobs or whatever? And there's like, I look, there's like teaching classes and be like in a summer camp for kids to learn coding and everything. Is that?
I don't know if it's the same thing or not. I haven't looked at the Clark version.
Because I was like, maybe that's the same thing.
Okay. I'll take a look at it. I have the information he gave me back in the office. I don't remember what the name of the company was. But yeah, there's a lot of opportunities like that, right? And I think it's definitely could be a cool way to spend your summer. All right, so we will talk about PA4 specifics in a second, but first we have to have the talk. And I hate giving the talk. I think I gave it in 224 at some point, and I don't like giving it in 222, but we gotta have the talk. The talk is about, yeah. So people sharing code or people using code that they find online as a starting point or maybe as an ending point in some cases. And this is a concern. And it's a gray area, right? I mean, I give you code. I write code up here. Sometimes it's pseudocode. Sometimes I write actual C code without semicolons. And if you look online and you find algorithms for doing things written in C code and you start from there as a description of the algorithm and write your own code, it's probably going to have a similar look and feel to these other sources. In the worst cases, I'll find code online that's verbatim what somebody has turned in, including the comments, including the spacing of the comments, right? And it's a huge red flag, so I don't run automatic comparisons. But there are tools that most schools will use. They'll take all the assignments students submit and run them through these automated tools, and they'll cross-compare. And they'll factor out things like variable names, indentation, things like that, and try to find commonalities. For me, I'm sort of getting to know your individual styles at this point. Right, I've seen enough of your code, I've worked with you enough, and coding becomes something that's kind of like a signature or a fingerprint, right? Everybody has their own style. You can sort of pick out code written by someone, and sometimes I'm looking at someone's code and I just see things that I've never seen from them before. Like, we usually write variables in here like number of steps. But if you use camel case, you would probably write this as number of steps. Or you might put underscores in between here, right? It's a stylistic thing. And sometimes I see things that just look very different style-wise. Or I see things that we've never talked about. And suddenly, for the first time, this person is using this new language, right? And when I encounter this, typically, I'll just grab a line of code and throw it into Google. And about half the time, I get Google showing me your source code. So I'm okay with people working together to understand concepts. I'm okay with going online to look for algorithms. And a lot of algorithms online are presented in the form of C code. Okay, the danger is if you look at an algorithm for, say, implementing a queue in C code, and then you say, okay, I understand how queues work, I'm going to write this in C now, it's really hard not to write the thing that you just saw, right? I mean, you can change variable names and things like that, but it's going to, more likely than not, end up replicating what you saw online. And the problem is that other schools, WSU, UW, whoever, generally have a no tolerance policy on this. If you even accidentally turn in a piece of code that has sections in it that came from a source online or that match a source online, that's probably it. You're in front of an honor board, and if they decide that this was plagiarized, you're out of the program, you're out of school, and it follows you for the rest of your life. Right? You go to another school and you're going to have to go through a whole negotiation about this. If you do this on the job, same thing. It's really, really serious. So I had a friend when she was in college, she was taking a biology class and she had to write a paper for it. And there were personality conflicts with the teacher. And that might have fed into this. but she got a notice after turning in her paper that she had to appear before the honor board. And she had a sentence in her paper with 7 words that were the same as the 7 words in a published paper on a similar topic. And it was something like, the total concentration continues to decrease, and some other 7th word. And that was all the teacher needed. And she brought her before the honor board, and it was a huge disruption to her education. She had to take time for this. She had to prepare a defense. She had to pull up her materials when she was writing the paper and be prepared to present all of that. And in the end, she was exonerated. They said, okay, you should have cited it because it was the same, but we believe you didn't know about it, right? But it was a huge deal. And I myself have been on the other side of this. When I was a sophomore, I was taking a programming class, and we were doing something similar to the word index, but it was supposed to index source code. So we were using Pascal, and we had to write a program that you could feed it the source code for a Pascal program, and it would show you all the variables, all the functions, where they were declared, where they were used, and all of this detail. So it was an indexing programming on a Pascal program. And we had a week to do it, and I did it in about a day, because that's all I did at the time was write code. And I turned it in the next class, and nobody else had it done. So the teacher gave an extension, which was kind of annoying. But my program worked perfectly. I turned it in on time. And the following week, everybody else turned it in. And the following week, everybody got it back. And I had a 20 on it. And no explanation. So I went up to the break and asked the teacher, why'd I get a 20? And he's like, well, I gave you 20 points for typing it in. But he said the code looked like something he had seen published in a magazine. And I started questioning him about it, and my friends kind of like pulled me back and made me go away for a while. But eventually I came back and I started questioning him about it. Well, here's the deal. This was what I looked like at the time, right? So good like 80s thing going on. And here's what this teacher said to me. My friends never let me forget this because they always teased me about it. He said, you know, I look at this code and I look at you, I don't see the connection. That was it. That was his basis for accusing me of plagiarism. And it turned out, you know, I was really good friends with like all the people in the department. All the faculty knew me. This person was an adjunct who had just come in to teach this course. And so we got it settled pretty quickly. But it's really, really easy for somebody to accuse you. And it's generally really hard to recover from that. So you got to be really careful. Okay, online sources are great. Geeksforgeeks.org has a lot of useful stuff in it, right? But be really, really sure if you're looking at code that you do the 3 hours of Gilligan Island reruns or something to clear that code out of your brain so that when you're sitting down in the editor and you're typing in code, it's coming from yourself, right? And not from your memory of a way to do this. Okay, does that make sense? All right, cool. That's the end of the talk. So having said that, let's look at code. Yeah. And my BroadestFirst search was using a different kind of queue, so I had to write a real queue-based traversal last night. But fortunately, I got that to work. Otherwise, it would have been really embarrassing. So here's a version of PA4. So I had one include file, tree.h, just to put in function declarations and you know, prototypes for functions and structure declarations. My intensely detailed comment up there, simple user interface for building and exploring BSTs. I got lazy with traversals, so I had one set of traversal code, and I was going to pass it an argument to say what order I wanted to do it in. And instead of just having magic numbers 1, 2, and 3, I just made some symbols, node left, node right, left, right, node, for the 3 types of traversal. So my main structures. So a tree node is a left pointer, integer data, and a right pointer. And then an uppercase node is actually a struct node pointer. So that's a shortcut. And my queue is a queue of nodes. So the data type is a node, and then I've got my next pointing to a queue node, and I've got my tail pointer pointing to a queue node. And this is straight out of PA3, except instead of being an int data, it's a node data. Okay. and then tons of function prototypes, which we'll get to. So the root of my tree is just called root. It's a struct node pointer, so it's a node. And it initializes to null. That's all you do to initialize a tree, set the root to null, right? Because we don't have a sentinel. So you don't really need a separate init routine, just make it null. And then my main input loop goes down to here. So print out my welcome message, and fgets to read a line. If you hit end of file, like if you're reading from a file, fgets will return null. That'll kick you out of the loop. And at the end of all of this, right, I just release my memory. So I just call release on the root of the tree, and then exit. So read a buffer, and then different ways that you can parse your input. But basically, your input has the following possibilities. It could be just a number, or it could be a command, or it could be a command followed by a number. Right, and so on. So to tell if your input starts with a number, use scanf. Try to scan with a %d. That'll tell you if there's an integer sitting in the beginning of your string. If you want to know if it's a letter X, you don't really need to use scanf. You could just say is buffer bracket 0 equal to an X. But you could also scanf into a %c and then see if %c is equal to an X and so on. If you want to know if it's something followed by a number, again, you could do a %c followed by a %d, or in this case, I could just do a d followed by a %d, or an s followed by a %d, and so on. So different ways to do that. But for me, I wanted to start with seeing if we had a number, because that means I want to insert something. So if scanf returns a 1, and that's better than saying if it's not 0, because sometimes scanf gives you something other than 1 or 0. So if this returns a 1, which means I do have a number, I search to see if it's in the tree, and my search returns null if it's not in the tree. So if it doesn't return null, then I just say error, that number's already in the tree. Otherwise, I go ahead and insert it. And so all these functions, root equals function root comma whatever. So this inserts the number into the tree and returns the root in the new tree. And that's the whole processing for when you just have a number. Otherwise, I don't have a number. And so now I chose to use a switch statement. You can do a bunch of if statements as well. So I switched on the first character of your input. So if it's an X, I call the examine routine, which does all of the output, different traversals, depth first, breadth first, height, etc., and then a break out of the switch statement. If you have a question mark, I call my usage function, which just says what are the valid commands. If you have an S, which says search, I go ahead and do an scanf to pick up the number. If that does not return 1, I can give a nice detailed error message. S should be followed by a number to search for. Otherwise, call search, save the result in temp. If it's not null, I can say we found that number. Otherwise, say the number is not in the tree, and then break out of that piece of the switch. Same thing for delete, right? Make sure you've got an actual number after that. If not, say D should be followed by a number. Otherwise, search for the number. If it's not in the number, that's an error. Can't delete it. It's not in the tree. Otherwise, call your delete function assigned back to the root. And then Q is your quit. tell the person you're freeing the memory, call the release function, and I just return from the whole program. Anything else, I print out a message that says, hey, enter question mark for help. And if they do a question mark, it'll give them the usage. And then at the end of the switch, print out a prompt and go back to the top of the loop. So that's the whole main program. And delete. All right, so delete, you pass it the root of the tree, you pass it integer data, and it returns the root of the new tree. So if root's null, just return null. That should never happen, but it's an edge case. So if you try to delete from an empty tree, don't do anything. If the root data is equal to the data you're trying to delete, so this is the big long case, right, where we want to delete the root of the tree. So all of this code is deleting the root. So if there's no left child, then just change the root to whatever the right child of the root is, free the original root, return the new root. Okay, so that's the case where we've got something like this. And this is null. And here's some subtree A. And all we do is change the root to point to root's right child. All right, the algorithm that I gave you every time we talked about deletion is replace the root with the largest node from the left subtree if it exists. The only exception is when there is no left subtree. In that case, move the root down. But about a third of the class also decided if there was no right subtree, they would do something different. They would move the root down to the thing that the root's pointing to on the left. That's a way to delete a node, but it's not the way that we asked for. Okay, so I took off a few points for that, not the full 10. All right, so if there's nothing on the left, move the root down to the root's right child, return that as the new root. Otherwise, we know that the left subtree exists. So I can set temp equal to root left. We know that's not null. If that node has nothing on the right, though, that's another one of our edge cases. So that's the case where we've got a root we're deleting. There's some stuff over here. There's a single node here, and then some other stuff hanging off of that. But there's nothing to the right of this node. And in that case, so this is temp. Temp becomes our root. And we just attach A to the right. So if temp right is null, temp right equals root right, free the root, return temp. Okay, that does that picture that we just saw. Otherwise, we have the general case. Which is where there's some subtree structure under here, and eventually there's a single node with some other subtree structure. And so our tree kind of looks like this. Let me draw one more node in here. All right, and remember our algorithm was to find largest and previous. And make largest the root, have it adopt this on its left, this on its right, and then have previous adopt largest left child as its own right child. So that doesn't become orphaned. So first thing we have to do is find the rightmost child. So while temp right is not null, and we know temp right exists, right? Because if temp right was null, we would have had this other edge case. So temp right exists, it has a right child, so we go until temp right is null. And as long as that's not null, we just move down to the right child. So this is a one-line loop that basically moves you to the previous to the largest node. Okay, so at this point, temp will be here. Right, so temp right is null. So temp right's the rightmost node, so we're going to return temp arrow right. That's the largest node. That's going to be the root of the new tree. And then temp right equals temp right left. So temp is the previous node, so it's adopting the largest node's left child. And then the new root's right is the old root's right. The new root's left is the old root's left. And then we free the root and we return that new root, RET. So that's all the deleting the root business. Otherwise, if our number is smaller than the root data, we need to delete from the left subtree. So call the delete function on the left subtree, take what it returns, and set root left equal to that. Otherwise, our data must be bigger than the root data. So delete what's on the right subtree, set the root right to that, and return the root. So that's deletion. Insert is pure recursion. So if the root's null, make a new node, return that. If the data is smaller than the root, insert into the left subtree and point root to that on the left. Otherwise, insert on the right subtree, point root to that on the right, and return root. So that's insert. Creating a new node is malloc a struct node, set the data, make the children null, and return the address of that node. And then traversal. So traversal was interesting. I saw lots of things with traversal. Your goal was to do 3 depth-first traversals. So pre-order, in-order, and post-order. And I got some really interesting traversals. I got some that I think were like right-left node, which is a way to traverse a tree, but it's different from any of these. In general, all of these, left comes before right. It's just the node that's being done in a different place. But I saw some of those. Some people did LNR twice, and there were different combinations. And a lot of times what I saw in the code was, I think, just cut and paste errors, right? So somebody did the in order, and then, which calls LNR, prints the data, calls LNR on the right. And then when they wrote NLR, they printed the node data, but they still called LNR on the left and then on the right, things like that. And cut and paste errors, those are easy to make. So, so traverse with a big T basically calls traverse with a little t, right? And it passes my order variable. And this does all 3 of the traversals. So if the root is null, we're just going to return, okay, because there's nothing to print. Otherwise, if we're doing node left-right, go ahead and print the root data. And then regardless, traverse the left subtree. If we're doing in order, go ahead and print the data after the left subtree. Traverse the right subtree. If we're doing post order, print the data after the right subtree. So that just uses the order variable. And then print data was how I dealt with the comma. And I felt bad after a while taking off a point for the comma on the end, but enough people had figured out how to get rid of the comma that I'm like, well, I can't really not reward them for doing that. So it was a penny for having a trailing comma. But I did kind of a cheat here. So my traverse uppercase T has this flag called new traverse, which gets initialized to 1 before I call my actual traversal. And I use this print data function to print out my actual integer. And print data just checks the value of this flag. If this flag is 0, it prints a comma, and then it prints out the data. And it always clears the flag. So since new traverse starts as a 1, the first time you call print data, there's no comma. It prints out the data, but now that flag's cleared, and every time you call it after that, it'll print out a comma. And I just initialize it to 1, saying this is a new traversal at the beginning of traverse. So that's one way to do it. Did anybody get rid of the comma by printing a backspace and a space? Okay. I didn't see that, but that works.
I didn't realize that the backspace, like the slash B, I didn't realize it was a thing.
Yeah, yeah.
I would have done it if I realized that, but whatever.
That works unless you pipe into something other than your screen.
How do you print the backspace?
It's ASCII character 8. There might be a backslash B might do it,
Yeah, that does it.
but you can also just do ASCII character 8, so do a %C with an 8, because Control H is backspace. All right, so my examine routine does all of the traversals. So traverse in 3 orders, do the breadth first traversal, print out the height and call the height function, print out balanced, and print out either yes or no based on the return of the balanced function. So balanced gives you a 1 or a 0. Right. This is all just modularizing on top of modularizing, right? I can write my examine function and then go off and, you know, celebrate because I'm done with my examine function, even though I haven't done anything, because I'm just calling other functions, right? But those other functions I have to come back and write are even smaller and simpler and do less. And eventually you write a few lines of code and then you're actually done. So search, if the root's null, I return null saying it's not in there. This is bogus. I don't actually return 1. Actually return a node. But so if the root's null, it's not found. If the data matches the root data, I return the root. Otherwise, return the results of searching either the left or the right subtree. So we've talked about that. Usage is just my pretty print of commands. So what you can do. Freeing all memory is a post-order traversal. Most people nailed this, which was awesome, right? So if the root's null, you're done. Otherwise, release everything from the left subtree and the right subtree, and then free the root. And that's a perfect way to do it. Yeah, I don't remember why I did that. I wanted to do something with it.
I did it so I could use that for delete instead of having it first delete.
Okay, cool. Nice. All right, and then breadth first traversal. So this was the PA3 Q code that I wrote. So a init Q returns a struct Q node star, right, which we pass around as our Q object. So initialize a Q, and I do this every time we start BFS. If the root's null, return, oh, there's a memory leak. Yeah, I should have done that before I initialized Q. My bad. Otherwise, take the root, insert it into the queue. So I use the add routine, puts the root into the queue. And then remove what's at the head of the queue. If that's not null, I'm going to do the following. So I print a comma as long as that's not equal to the root. So that's how I make it not have that trailing comma. And then I print out the data. And then if the left child's not null, I add that to the queue. If the right child's not null, I add that to the queue. And then go back up to the top of the while loop. So that's the essence of the traversal code. Right? So remove the head of the queue, print its data, add its children to the queue. Right? That's your 3 steps, and it's seeded with that initial up here. And then at the end, I call my exit queue, which was the release of memory for the queue. All right, so that just gets rid of the sentinel and all the other stuff in the queue. All right, height is recursive, so if the root's null, return -1. Null tree has height of -1. Tree with just a root has height 0. Okay, height is the depth of the deepest node. Depth is the number of edges from the root to a node. So if there's just a root, the number of edges from the root to the root is 0. That has a height of 0. Okay, null has a height of -1 by definition. So a few people were off by 1 on the height. Make sure you know empty tree has a height of 1. Geeksforgeeks.org actually got that wrong. They did a height of 0 on empty trees. Should be -1. So if the root's null, return -1. Otherwise, find the height of the left and the right, add 1 to each of those, and then this just returns the maximum of those two heights. So whichever one is greater, that's the one we return. So that's height. And then balance. So as far as I know, I have never in this class or in my life said to find balance, all you got to do is check the height of the left and right subtrees. Question? That's a ternary operator. So you can say condition, interrogate, expression true, colon, expression false. And this whole thing is equivalent to either ET or EF. ET if condition is true, EF if condition is false. So this basically gets replaced by one of these two things on either side of the colon. So in this case, if H1 is bigger than H2, this whole expression is just equal to H1 and it returns H1. Otherwise it returns H2. It's just a shortcut. Yeah, you can return it. It's really just replacing this expression with one of these things. So it could be a bool, it could be a pointer, it could be anything. It could be a string. Yeah, I'm just doing an int, so. So balance is more complex than just comparing the height of your left and right children. And the example that we gave when we talked about this was this. The left and right subtrees have exactly the same height, but this is absolutely not balanced, right? It's not full at the upper levels. So one criteria is to make sure that the height of the left and right subtrees are within one of each other, but you also have to make sure the left subtree is balanced, and you have to make sure the right subtree is balanced. So you got to satisfy all three things for the tree to be balanced. Heights are close, left is balanced, right is balanced. If all of those are true, or if the tree is nulled, it's balanced, otherwise it's not balanced. So that's all that this code says, right? If root's null, it's balanced. Find the height of the left and the right. Found the absolute value of their difference. If that's bigger than 1, it's not balanced. If the left or right subtree is not balanced, it's not balanced, otherwise it is balanced. It's a little word salad, but it works. And then the Q stuff, we saw this in PA3. This was my version of PA3. I just hacked out the stack stuff and changed all my integers to struct Q node stars. So not a whole lot to say in here, but basically the data in your queue is actually a struct node star, right? A pointer to a tree node. And nothing else really changes in here, right? You just change the type of variable that you're passing in and passing in a node data instead of an int data, but all of these statements are the same. So I didn't have to make a whole lot of changes on this stuff. All right, so things I saw. So put your name in your code, right? Put comments in the beginning of your program. Try to tell the user what this program's for. You're probably going to go back to this program at some point, right? You may be working with trees at another school. You may be looking for samples for an internship or something like that. And it's kind of nice not to have to go back into your code and add comments, 6 months after you wrote it, because then you got to reverse engineer it. So, talk a little bit about what the program's doing. You wrote it, the date, the class, things like that. But definitely include your name in there. So weird traversal orders, took off a few points. Straight commas was 1 point. Memory leaks. So lots of opportunities for memory leaks. I was really, really happy with how many people had no memory leaks, which was awesome. because you got to deal with deletions, you got to deal with cleaning up the tree at the end, and you got to deal with leaks from your queue. And a lot of people dealt with all of those perfectly, so that was cool. Lots of delete issues, obviously, right? That's never a surprise. There's so many things that can go wrong. So typical things you can see when you delete, one is just not deleting, okay? But that really doesn't happen very often. More common things are you delete the node, but it gets replaced with something else. Could be a 0, could be a weird negative number. And that's some pointer that's not being moved to the correct thing. Occasionally you delete something and the next time you try to traverse, it just prints forever until the stack blows up. Yeah, and that's a pointer that instead of pointing where it's supposed to is somewhere pointing to a previous location in the tree. And your poor traversal algorithm just keeps chasing its tail and going deeper and deeper down the stack. Yeah. So that's not uncommon. And the other thing is sometimes you delete a tree and you delete a node and huge chunks of your tree vanish, right? And that's sometimes just not letting the previous node adopt the largest node's left child, or some other pointer changing in a way that it wasn't supposed to. So lots of ways that delete can go wrong. Some seg faults on exiting, which is usually from trying to free the memory, and something's going wrong in there. Maybe you're freeing the memory before you're following its children or something. Height off by 1, not a big deal, it's just a definition. Saw some variations on what the assignment actually asked for though, right? I tried to be really explicit about how to label the output and how to format the output, and in some cases that wasn't happening. So I took off some points for that just because I want to make sure people are in the habit of being able to work with those kinds of details. I did not take off for warnings or errors from Valgrind as long as you did not have memory leaks. But I didn't have to, because in most cases when you were getting errors from Valgrind, you were also having problems with things like delete or maybe breadth first search. So pay attention to those warnings, right? Come and talk to me if you can't figure out where they're coming from. They usually mean something. Sometimes it's something harmless, but sometimes it's something pretty serious, and it can come back and bite later on. I think that was about it. So any questions or comments on all of that? Yes. Yeah. This was definitely the worst programming assignment in this course, right, in terms of amount of work required, not in terms of how you did, but in terms of how much work it takes to do this, right? This was by far the most complex. It's also the most difficult to grade because you just have sheets of all these different trees and traversals and and things like that. So I tended to look more detailed at people's code, and sometimes I see code that's just doing something really quirky that I can't figure out, and then I'll really dig down into it and try to see what's going on. But if you've got pending questions on this, let's definitely talk. Okay. You need to know how to do these things to be successful on the final. Okay, I'm not going to ask you to mimic your delete algorithm on the final, but the kinds of things you do, finding the largest node in the left subtree, right? Stuff like that, you want to totally be able to do, because we'll have pieces of that on the final. I'll have things that are different from finding the height or the balance of a tree, but similar in feeling, right? Working with a recursive definition and being able to code that. So definitely come and talk to me if you're not sure what the issues were on PA4. Make files looked good. So no corrupt tar files, first of all, that was good. So didn't have to send anybody back to retar. Make files looked pretty good. I made a few comments where I noticed sort of obvious things to me on makefile issues. But by and large, no problem with those. Everything made the way it was supposed to, so that was good. Anything else? I think that's it. All right, any questions on knapsacks? All the questions? Did everybody turn in their SLP poster? Almost forgot about it, but you didn't. Okay, it's actually open until 1 o'clock, so if you know anybody who forgot and you like them, you can tell them to. Yeah?
I have a question. So for the SLP communication, do you have to do it in the class or
Just the digital lounge. Tuesday, 3 o'clock to 5, not tomorrow, a week from tomorrow. Yeah. Yeah, and we're sending things off to the printer for you. Yeah, very similar to last quarter, except you're going to have all this great progress you've made. And you're going to understand your project even better, so it's going to be even more exciting. And we're moving towards spring when we have sort of the big expo. All right, cool. So tomorrow I want to talk about one more example of recursive, of dynamic programming. We're going to look at dropping eggs. And then we will start talking about sorting and searching. And we'll go through some different algorithms for that. So I will see you next time.